Morning to everybody. Today I have the pleasure to have with us Michael Dennis. Michael is the Vice President of CAS. Hi, Michael. Good to see you.
Good morning.
How are you? Okay, good morning. So, CAS story is now more than 110 years long. And it is known by the chemists all around the world as the world's largest collection of chemistry and science. Can you tell us how the spread of this data has changed in the recent decades, especially with the advent of new technologies?
Well, yes, the volume and complexity of global published scientific literature, including patents, has grown exponentially in the past decade. So, for example, in China, we're just seeing tremendous growth in the amount of scientific information, but also the quality of that science. And CAS has adapted, so we're covering all of that information for researchers all around the world. Our content is still curated by our CAS scientists, but to keep up with that growth, we're augmenting their capabilities with technologies, and we keep improving those technologies. So to demonstrate the growth in discovery, take the CAS registry. It's the world's largest collection of small molecules. It took us 40 years to register the first 25 million compounds. But in the past 4 years, we've registered over 50 million compounds. So it's now over 160 million. And of course, it's not just the substances, it's all the properties, the reactions, and the other information in the registry. But beyond the volume growth, we've expanded our scope to cover new disciplines, new geographies, new sources, new data types. So one example is formulations. So you might say, what's a formulation?
Yeah.
So think about a drug, right? It's typically not one compound, but it's a formulation or a mixture of many chemicals.
Can be different, very different things.
Yes.
And different results.
Absolutely, or cosmetics, sunscreen to block UV. It's a formulation, or herbicides, pesticides. So we now have taken that information and we've created a solution called Formulas to help the needs of scientific formulators in the industry. And we're quite proud of that. And we have more new solutions like that coming.
I see. So big, huge number of molecules and, situation.
Yes.
Okay, we used to consider, and I am a chemist, so we used to consider CAS as a source of information for chemical research. Is still the same, or does it embrace other fields of science?
Well, CAS, we are a division of the American Chemical Society. So chemistry, it's our heritage, it's our roots. But we define chemistry very broadly.
Very broadly, yeah.
Right, so we it's the central science. So we divide chemistry into 80 sections. And on one end of the spectrum would be physics and engineering. And on the other end of the spectrum would be biology and medicine, and then everything in between. So it could be coatings, material science, organometallics, and so much more. And we do that because researchers around the world, right, they demand that type of information to further their innovation. And we're seeing less maybe bright boundaries between disciplines. We're seeing a dimming. It's a good thing. So, for example, we see where biology, chemistry, and medicine are converging. And so we've adapted, we've pivoted, and we're covering much more information to serve those researchers, like target information, diseases, biological activity. So we're expanding the reach of CAS.
Okay, thanks. Can you briefly tell us something on your product SciFinder? And because I'm sure that our audience could be very interested in learning more. Can you tell us briefly?
Yeah, we're excited about SciFinder N. So this is our flagship product. SciFinder N is the most advanced solution in the SciFinder family. It was built to help researchers eliminate their productivity bottlenecks and accelerate their innovations to market. It has all of the CAS content, our broadest collection. It also has the advanced relevance engine. I would suggest it's the best in science, but it also has something called predictive analytics. And you might say, what's that? Let's say you want to make a molecule, you want to synthesize something, you're a chemist, and SciFinder N will provide you with all of those reactions from the literature, all those empirical reactions from patents, journals. But maybe today we want to make something that no one has made before. Let's say it's maybe something that looks like remdesivir, but again, never been made. SciFinder N has an advanced predictive analytics engine that will predict a pathway. So very, very exciting. So it will give us a head start, almost like having a lab partner that will help us get answers.
It seems very exciting, it seems. Okay, Michael, let's now speak very quickly about the emergency of the moment, so COVID-19. So, and try to explain the work that the CAS has been doing to support the R&D efforts to treat COVID and to make more people aware of these resources. So what role does an organization like yours play in addressing urgent issues such as this?
Well, as I mentioned, CAS is a division of the American Chemical Society, and our mission is to improve people's lives through the transforming power of chemistry. And we take that mission very, very seriously. And we know that information, science, is going to ultimately find that treatment and cure for COVID-19. So under the leadership of our president at CAS, Manuel Guzman, we've opened up all of our resources, all of our assets, our content, our technology, and all of our people to any organization that's researching a discovery for the cure for COVID-19 at no charge. And the response has been overwhelmingly positive. Our scientists have also published seminal research papers on the status of COVID-19 research. One was published in the open source journal, TKS Central Science. And it was downloaded over 250,000 times in the first 2 months. So phenomenal interest. And then lastly, we've been creating unique data sets for free in the COVID-19 space. So one is a COVID-19 antiviral candidate compound data set, where we took all the known antiviral compounds, and then based on chemical shape and biological activity, we expanded that roughly 50,000 candidate compounds for a treatment.
So good job, and thanks for everybody. I am the first that I have to say thanks for your job, because in such a critical moment, this kind of information, this kind of work, I mean, are really the work that help the world. So thanks a lot. So, Michael, I need to say hello because now the time is very, tight. Sorry for that. I mean, I thank you again for the explanation that you gave us, the information that you gave us. I thanks for your time. And I'm sure that the readers, our readership, our audience will be very interested on what you told us. So thanks a lot and stay well. Ciao.
You too. Thank you so much. Ciao. Bye now.
Ciao.